Right, we're coming back to lesson 2 of Unit 2. We are going to be adding and subtracting radical expressions. Last time we were simplifying it, so now we're going to simplify and then do something with the radicals, okay? We're going to add and subtract today. So I guess you can guess what we're going to do the next lesson. Okay, like radicals, first of all, we need to know what like radicals are. So I think you probably have heard like terms, right? Like terms. And remember, in polynomials you can only add or subtract like terms. Same thing with radicals, you can only add or subtract like radicals. So what exactly are like radicals? So for like terms, we would consider like terms to have the same variable and same exponent, right? So for example, 3x squared with 5x squared, y and y, right? Those two will be like terms because they have the same variables x and x with the same exponent 2 and 2, and they have the same variable of y and y with exponent of 1. Okay, so these two will be like terms. Now like radicals is actually similar, okay, similar. So they must have same radicand and index. Okay, same radicand and index. Also, if there is, I guess this, if there is a what should I call this? If there's like a coefficient in front of the radical, okay, they don't have to be the same number. However, if there's a variable attached to the number, the coefficient, then they have to be the same. So for example, okay, I'll show you some examples. So for example, square root of 2x and 4 times square root of 2x. Yes, these would be like radicals. This is what I mean, okay? So x times square root of 2xy and 2x times the square root of 2xy. They are also like radicals, okay? Again, the 2 here, again, the numbers, they don't have to be the same, right? Here's 1 and that's a 2. That's okay. They are same, they're different. That's okay. However, that's an x and that's an x. They have to be the same. So what's not, well, in this case, they won't be like radicals. For example, we have 2x square root of 2xy and let's say 2 times square root of 2xy. They are not like radicals because in this case there's x here and there's no x there. You cannot combine these two together, okay? Also, they are not like radicals. And let's say we have 3xy, right? They are not like radicals because the radicands are not the same. One's a 2, one's a 3. These two will also not be like radicals. Let's say 2x squared y, right? That's an x, that's x squared. So they are not like radicals. Okay, so hopefully you understand what like radicals are. Okay, and we are going to do something about them in today's lesson. Before we do that though, we're going to actually review quickly about the polynomials that we've done before in the past. Let's see how we simplify these. So we are adding polynomials here. We have 2x plus negative 3x. Recall that's just 2 minus 3x, or 2x minus 3x, that's negative x. Negative 3y plus y is negative 2y. Positive 4 plus negative 3, that's like 4 minus 3, so that's positive 1. So that's the answer. Part B, we are subtracting. That's negative 4x minus negative 2x. So again, minus negative means a plus. So negative 4 plus 2 is negative 2x. 5y minus positive 3y, that's just 5y minus 3y, so that's plus 2y. That's positive 2 minus negative 1, so that's 2 plus 1, so that's plus 3. There's the answer. Finally, the last thing I'm going to show you before we actually do something with the radicals is the distribution, right? Remember, this is distribution, right? You got to multiply first before we can do anything. So that's 2 times x, 2x. 2 times 2y is 4y. 2 times negative 2 is minus 4. Negative 3 times x, so same thing, again, distribute. Negative 3x, negative 3 times negative 3y is positive 3y. Negative 3 times positive 1 is negative 3. Combine like terms together now. 2x minus 3x is negative x. 4y plus 3y is 7y. Negative 4 minus 3 is negative 7, and that's the answer. Okay, now let's get to it. Radicals. So again, note, remember, you may only add and subtract like radicals, okay? Like radicals only. Okay, problem. Not like radicals, right? Root 27, root 12, root 8, they are not the same radicants. However, we can turn them into like radicals, right? Root 27, I know that is the same thing as square root of 9 times 3. Root 12, that is the same as square root of 4 times 3. Root 8 is square root of 4 times 2. Okay, so I can simplify it first before combine them. Okay, so root 9 is simply 3. So this is 3 root 3. Root 4 is 2. So that's 2 root 3. 4 square root of 4 is 2. So that's 2 root 2. Now you can see these two are like radicals, right? Same radicand. Okay, same index. The coefficient is not the same. That's okay. 3 plus 2 is 5. So 5 root 3. Just like 3x plus 2x is 5x, right? So 3 root 3 plus 2 root 3 is 5 root 3 minus 2 root 2. There you go. There's nothing you can do about 5 root 3 and 2 root 2 though, right? You can't do that. It's like 5 apples, take away 2 oranges. There's nothing you can do about it. It's just 5 apples, take away 2 oranges. The end, right? Nothing you can do about that. Okay, moving on to number 2. Square root of 27 xy. Again, I can simplify this first. That's 9 times 3 xy. That's 4 times 2 xy. Okay. Square root of 9 is 3. Square root of 3 times square root of 3xy plus square root of 4 is a 2. So 2 times root 2 xy. Not like radicals. That's a 3. That's a 2. Not the same. Nothing else we can do. Done. The end. Okay. Again, 3 apples, add 2 oranges, you can add them. Unless you make it into juice or something, I don't know. Well, but that's not what we're doing, okay? We're adding 3 apples with 2 oranges. Nothing you can do about that. You can't say we have 5 apple oranges. Okay, there's no such thing as apple oranges, okay? Go ahead, try these two. Okay, so I'm assuming you're finished. This is going to be 4 times the cube root of 8 times 2. Plus 3 times the cube root of 27 times 2. So this is 4 times cube root of 8 is 2. So 4 times 2. And then cube root of 2. Plus 3 times cube root of 27 is 3. So 3 times 3 times cube root of 2. Now this, okay, so 4 times 2 is 8. So this is 8 cube root of 2. Plus 3 times 3 is 9 cube root of 2. They both have cube root of 2, so like radicals, add them together. So now we can add them, right? 8 apples plus 9 apples, 17 apples. So 17 cube root of 2. Okay, number 4. Root 20 is 4 root 5. So 4 times 5, sorry. 18 is 9 times 2. 45 is 9 times 5. 50 is 25 times 2. Okay, so again, these are all perfect squares. And they are factors of those radicands. Okay, so this is 2 root 5 plus 3 root 2 plus 3 root 5 minus 5 root 2. Okay, we have these two as like radicals and then these two as like radicals. We can definitely combine them together. 2 plus 3 is 5, so 5 root 5. 3 minus 5 is negative 2, so minus 2 root 2. And that's your final answer. Okay, so these are just numbers. Hopefully they're not too difficult for you because we are going to actually move on to some variables. Okay, I will show you the first 2, okay, and I'll let you try the other ones. Okay, number 5. So, well, this one's easy because they are just like radicals, right? 5 root x, 3 root x, 4 root x. They are like radicals. Same radicand, same index. Simply add them and subtract them. 5 plus 3 is 8. 8 minus 4 is 4. So 4 root x, done. That was easy. Okay. Number 6. Okay, now we need to do some work here. Square root of 25 is actually 5. Square root of a squared, that's actually absolute value of a. I don't know if you remember that, okay? So be careful because we're not defining the variables here. And we're taking the square root of a squared, which means it's just going to be a. But we need to consider the negative case, okay? And a could be negative, but we will never get an answer that is negative when we take the square root. So you must have absolute value symbol here, okay? Plus, square root of 4 is 2. And again, square root of a squared is absolute value of a. And we still have the root b there. Now we can add them together because these are like radicals, right? Same radicand, same index. It's absolute value a in the front, absolute value a in the front as well. 5 plus 2 is 7. So 7 times absolute value of a times root b. Okay, so that's that. Okay, so be careful when you have even roots, even index roots. Be careful. As long as this is not an even power like a squared or a to the power 4, you need the absolute value symbol. Okay, so good luck. Okay, I will show you how they are done. Fourth root of 81 is simply just 3. Fourth root of p cubed is nothing we can do. However, fourth root of q to the power 5 is absolute value of q. And what we're going to end up with is we're going to end up with p cubed and a q inside. P cubed and a q. That's a lot of cube there. Okay, because q to the power 5 can be broken into q to the power 4 times q. Okay, so there's the q we can take out there, but we still have a q inside. Okay, minus 2. Again, that's a fourth root of q to the power 5, so we can take out the absolute value q, and there's nothing we can do about the p cubed, so we have p cubed and a q there, same radicals, or like radicals I should say. 3 minus 2 is 1, so your final answer is absolute value of q times the fourth root of p cubed q. Okay, number 8. This one is easy. Just look for like radicals. 2 root x plus 5 root x. That's 7 root x. Negative 3 root y plus 2 root y is negative 1 root y. And that's it. Number 9, same thing. Like radicals. 8 minus 5 is 3. Cube root of 2x. This is 7 root 2x plus 1 root 2x, so that's 8 root 2x. Okay. Number 10, this is a square again, so you might need to watch out for the absolute value symbol. However, it does tell you that x and y are both equal to or greater than or equal to 0. So we will never get the negative case when we have just one single x outside of radical. So in this case, we actually don't need to worry about absolute value sign. Okay, so which makes it easier. Okay, so we have 5. This is 4 times 2 x squared. Okay, fine. Okay, it's kind of a lot. Okay, I'll show you everything. That's okay. I might need more space, so I'm gonna borrow some space from here. So 8 is 4 times 2. Okay, I'm not gonna use the times symbol, I'm gonna use dot. Dot x squared dot x plus 4y. This is 25 times 3 times y squared times y minus 2. 27 is 9 times 3 times y squared times y squared times y. Finally, minus 3x. 50 is 25 times 2 times x. Oops. Okay, so now we can simplify this a little bit. Root 4 is 2, so 2 times 5 is 10. We have square root of x squared, that's just x. Now again, we don't need absolute value symbol in this case because it already tells us that x and y are both greater than 0. We still have square root of 2x inside, however, plus square root of 25 is, square root of 25 is 5. 5 times 4 is 20. Square root of y squared is y. Combined with this y here, we actually get y squared. And we still have 3y left inside the radical sign. Minus square root of 9 is 3. 3 times 2 is 6. We have y squared twice, so when we square root those out, we actually end up with y squared here. We still have the 3 left and the y there. Okay, so that's still there. minus square root of 25 is 5. 5 times 3 is 15. So we have 15x square root of 2x. So you can see there's my like terms. Okay, 10 minus 15 is negative 5. So negative 5x square root of 2x. 20 minus 6. Again, they are like terms because y squared, and the radicand are both 3y. 20 minus 6 is 14, so plus 14 y squared square root of 3y. That's your final answer. Okay. 2 more questions to go. Find the perimeter of the triangle. So this you need to use Pythagorean theorem. Okay, because again, hopefully you remember what perimeter means. Perimeter means you add up all the sides of an enclosed shape. Okay, an enclosed shape. So this triangle, the perimeter of this triangle will be this plus that, right? You add up all the sides. Okay, so you need to use Pythagorean theorem to find the hypotenuse side. Hopefully you remember Pythagorean theorem. It's a squared plus b squared equals c squared. I'm just going to call this h for the hypotenuse. Not for Mr. H, but for hypotenuse. Okay. Square root of 12 squared is 12. Square root of 27 squared is 27. This is h squared. 12 plus 27 is 39. This is h squared. So h is equal to square root of 39. Okay, square root both sides, you got root 39. To find the perimeter, you simply add them together. So root 12 plus root 27 plus root 39. You always simplify, okay? So root 12 is the same thing as equals square root of 4 times 3. 27 is 9 times 3. 39, there is no perfect square factor, so we just leave it as root 39. So this is 2 root 3 plus 3 root 3 plus root 39, which again, like terms, add them together, 5 root 3 plus root 39. This is the perimeter. Meters, don't forget your unit. There you go. Okay. Always keep in mind of your unit. Number 12, last one here. A square with an area of 24 square units is placed beside a square with area of 50 square units. There's a typo here. Okay, so we have, I'm going to draw the bigger one first. Here is 50. We have a smaller square of 24 square units. Okay, in simplest form, write the radical expression for the perimeter of this shape. Now, if the area of a square is 50, that means the side length is just the square root of that. So this is root 50, this is root 50, and this is root 24, root 24, root 24, root 50. Okay, so we are missing one side, which is that side. Well, what is that? Well, that's the whole thing. Take away this side, which is root 24, right? So that's root 50 minus root 24. Okay, so that's that portion, right? That's the entire side length. Take away the smaller square side length. So root 50 minus root 24. Okay, now to find a perimeter, we simply add up all these numbers together. Okay, so that's root 50 plus root 50 plus root 50 plus root 24 plus root 24 plus root 24 plus the last one, which is root 50 minus root 24. Okay, so that's the short side there, I guess. Okay, so now we can add them together. Well, that's 1, 2, 3, 4 root 50s. We have 1, 2, 3 root 24s, but taking one away, so 2 of them. Okay, now we can simplify this. 50 is 25 times 2 plus 24 is 4 times 6. So this is going to be root 25 is 5. 5 times 4 is 20. Square root of 4 is 2. 2 times 2 is 4. Root 6 is remains. Units. This will be the final answer. Because you cannot combine them, right? They are not like terms. So that is it. Okay, so that's the end of this lesson. Okay, hopefully again not too difficult. It's a lot of work, okay, a lot of calculations, so you could make silly mistakes here and there, so be really careful. Okay, take your time, don't do it in a hurry. Okay, do some practice questions. Let me know if you have any questions. Good luck.